Hello, welcome to my YouTube channel. This will be explaining prove the identity sine cubed theta is equals to 3 over 4 sine theta minus a quarter sine 3 theta. Solution: you have been asked to prove that sine cubed theta is equals to 3 over 4 sine theta minus a 1 over 4 sine 3 theta. Remember, sine theta is given by e raised to power I theta minus e raised to power negative I theta over 2I. So sine cube theta, it is sine theta times sine theta times sine theta, meaning that I shall take this e raised to power I theta minus e raised to power negative I theta over 2I times this times this. Are we there? So sine cube theta is equals to e I theta minus e raised to power negative I theta over 2I cubed. Okay, so this is e I theta minus e raised to power negative I theta over 2I e raised to power I theta minus e raised to power negative I theta over 2I. Are we there? So e I theta times e I theta is e I theta plus I theta. This times this, it is minus e I theta minus I theta. Then this times this, it is minus e raised to power negative I theta, this one, plus I theta, this one. Are we there? Then negative times a negative is a positive, so it is plus e raised to power negative I theta minus I theta. Remember, the law of indices is what we are using here. The law of indices divided by 2 times 2I times 2I, it is 4I squared. And remember, the square I squared is equals to negative 1, so it becomes negative 4. We can just write 4I squared first. So this becomes e raised to power 2I theta plus I theta is 2I theta minus e I theta minus I theta is 0 minus I theta plus negative I theta plus I theta, it is 0. Then plus e negative I theta minus I theta is negative 2I theta. The whole of this we divide by negative 4. Negative 4, remember, I squared is equals to negative 1. I squared is equals to negative 1. Okay, so this becomes e raised to power 2I theta minus any number raised to power 0 is equals to 1. So this 1 minus 1 plus e raised to power 2 I negative 2I theta, whole of this divided by 4. This becomes what? 2 it is e raised to power 2I theta plus e raised to power negative 2I theta minus 2 over negative 4. Then we multiply again with this one. E, remember it's cubed. Are we there? So we multiply again. This is just the square. This is sine squared. Now we multiply another sign, so that we get sine cubed a I theta minus e negative I theta over 2I. Are we there? So e raised power 2I theta times e raised power I theta. Remember, we have the same basis. Are we there? So we have e 2I theta. Remember the law of indices. Then plus I theta. Then this time, this again, it's negative e 2I theta. This one minus. Remember, plus minus is a minus. I theta. Then this time, this, it is plus e raised by negative 2I theta. This one plus I theta. Then this time, this minus e negative 2I theta. This one minus I theta. Then negative 2 times 2 raised by I theta. It is negative 2e I theta. Then negative 2 times this one, we get negative. It is a positive now. Negatives are positive. 2e raised power negative I theta. Are we there? Divide by negative 4 times 2I is negative 8I. Okay, let's simplify. 2I theta plus I theta is e raised power 3I theta minus, this is e, 2I theta minus I theta is I theta plus, this is e, negative 2I theta plus I theta is negative I theta minus 2 e raised power negative 2I theta minus I theta is negative 3I theta minus 2 e raised power I theta. They remain I theta plus 2 e raised power negative I theta. The whole of this we divide by negative 8I. After that, we collect like terms now. Like terms, you can see this one, this, and this are like terms, the same powers, so you can see. Then this and this are like they are like terms. Are you there? They are like terms. The same negative. I theta, the same powers. So we have e raised power 3 I theta, this one, minus e I theta, this one, then minus 2 e raised power I theta, this one, minus e negative 3 I theta, this one, okay, plus e raised power negative I theta, this one, plus 2 raised power e 2e raised power negative I theta, this one, the whole of this divided by negative 8I. And now this becomes e raised power 3 I theta. Out there, this negative e I theta raised power I theta minus 2 e I theta, it is negative 3 e I theta minus e negative 3 I theta, this plus this, it is 3 e negative I theta, the whole of this over negative 8I. For that, we put them into two groups. The numerator, I put it in two groups according to the arrangement. You can see have 3e I theta, 3e negative I theta. They say the arrangement is the same, but this one e raised power 3 I theta, e raised power negative 3 I theta, the same arrangement. So we have negative 3 e I theta plus 3 e negative I theta, this and this out there. Then you have plus E3 I theta, this one, minus E3 negative I theta, this one out there. The whole of this over 8I negative. Okay, so at this point we can separate the two, this part and this part. This way, that 1 over 8I negative into 3 E I theta plus 3E negative I theta plus 1 over 8I into E3 I theta minus E negative 3 I theta. Okay, this can be written as 3 over 4. Remember here you have a negative. 3 over 4 into E I theta minus negative is a positive, is a negative. Negative positives are negative. Negative negatives are positive. So E negative I theta. Remember I have factored this 3 out. This is 3. Okay, plus this 2I right there. So that 2I times 4 is it becomes what? It becomes 8I. Plus 1 over 4 E 3I theta minus E negative 3I theta over 2I. Remember here we have what? We have a negative. But sin theta is given by E I theta minus E negative I theta, as you can see, over 2I. So this one, the whole of this one becomes what? Sin theta. So it is 3 over 4 sin theta. Negative times positive is a negative. A quarter sin 3 theta. This 3 is because of this power here. Are we there? This 3 is because of this power. Because if you remove this power, it just remains sin theta. But we have 3 here, so it is sin 3 theta, which is equals to what? Sin cubed theta. And now we have proved the identity. Can compare and see. Thank you so much for watching. Till next time, bye.